right, so we stopped here yesterday, and we had found the maximum value. Remember that whether or not it's still the point itself is still the maximum or minimum depends on the graph and how it gets reflected. So you got to pay attention to that. All right, so if we want to find the f inverse of 3, if I'm looking for the inverse, where do I go to first on my graph, the x or the y? The y. So f inverse of 3, let's write this down. F inverse of 3 means I go to the output value of 3 and figure out what that input value is, and that is 2. So then f inverse of 1, what would that be? I go to 1, and that gives me 3, right? Looking for the ordered pair where the y value is 1, x value would be 3 there. Okay, we okay with all that? All right, good deal. So then it asks me for the domain of f inverse. Okay, domain of f inverse. Well, we didn't graph the whole thing, and we don't need to. But the domain of f inverse is the same as what from f? If x and y get switched, domain and what gets switched? Range. So for f of x, the range, I start down here at -3, and I go to 7, right? So then that means the domain of f inverse is the same thing, going from -3 to 7. You don't have to regraph it. You don't have to overthink it. You just need to know that domain and range switch places. Okay? Everybody good with that? Any questions? All right. So let's look at example 4. The function g is defined. So here's g from -3 to 10. And then g inverse is the inverse, which we don't see. Values of the increasing function h. So it's telling me that because if it's always increasing, then that means h does have an inverse function. So h is here in my table. And I'm going to find the following if possible. Okay, if possible. So I want g of h of 6. All right, so that first means I want to find h of 6. What is h of 6? 10. So then I really want g of 10. What is g of 10? -1. Okay. Any questions about where any of that's coming from? All right, so then I want g inverse of h of 0. So g inverse, what is h of 0? 3. h of 0 is 3. And then what is g inverse of 3? 4. Good, because that came over here, and that's 4. Any questions about that? All right, so then h inverse of, what is g of 8? 0. And then h inverse of 0? -1. Everybody good with all that? All right. Then I need h inverse of g inverse of -1. So what is g inverse of -1? 10. Okay. What is h inverse of 10? 6. Okay. And then I'm going to give you one more here. We're going to do g inverse of h of -5. Okay. What is h of -5? -3. All right, so then I'll need g inverse of -3. What is g inverse of -3? if I go here, do I have an x value on my function there? No. So this is not possible. This is why it says, if possible. Sometimes it's not possible. Like I can't, that's not defined. I don't know. Same thing as if I asked you, what is h of 1? Can you tell me what h of 1 is? Not possible for you to define. So it says, that's why it says find the following if possible. It is possible for you to have a not possible. Do you need to put your baby in the nursery? No, you're good. All right. Any questions? All righty. So then, now we're on to the next page, right? Did I scroll right? Okay. So this is also going on what, 62? Sorry, it's been a minute. It's been a week, let me tell you. Okay, 62. Why is this flashing? Okay. 62. Find my paper here. Here we go. All right, the horizontal line test, which I think I said yesterday that we were going to talk about in just a minute, but we didn't get that far. So we know what the vertical line test is, right? Y'all are familiar with that. If I have a parabola or any function, and we know that it passes the vertical line test, right? And you know, anywhere you draw a vertical line, it's only going to intersect at exactly one point. That's one thing that makes it a function. So that's one way to recognize that it's a function. Again, not good enough for us to explain it that way. If I take the inverse of, or if I draw the inverse of the parabola, it looks like that. So the inverse fails the vertical line test. Does that make sense to you? Instead of drawing the inverse and then looking, we could just start with the original one and do the horizontal line test. You see how that's the same thing? So the horizontal line test can tell you that if what the relation that you have, whether or not its inverse is a function. So vertical line test is what I have in front of me, a function. Horizontal line test is the inverse of what I have in front of me. Is that a function? Okay? And so that has to do with every input has exactly one output, or every output has exactly one input, that sort of thing. And so this says every horizontal line intersects the graph of a function f at most 1 point. Then it is 1 to 1. 1 to 1 means what you have is a function and the inverse is a function. Okay? But remember, even though we can talk about the vertical and horizontal line test, not enough for us to actually explain it that way. We got to have all those other words that we talked about. Okay, properties of inverse functions then. And some of this is a repeat again, but that's okay. So graphs of inverse functions are reflections in the line, which line? Y equals x. Very good. And that's what this line is right here. This is the line, y equals x. Okay, so if I have f of x, the inverse notation is f inverse of x. And that's something we just talked about on the other side. The domain of a function is equal to the range of the inverse function. And the range of a function is equal to the domain of the inverse function. Okay? X and y switch places, domain and range switch places. Any questions at all? All right, awesome. Okay, so now we are going to graph some stuff. Do you have to actually graph something on the AP exam? No, you do not. However, we are going to graph some things because I want you to understand some graphs. We should understand our parent functions. This is a square root function. The parent function for that looks like this. Okay. Then we have transformations in there because that would just be y equals square root of x. What does this plus 3 mean I do? Go to the left 3, and what does that minus 2 mean I do? Go down 2. Okay, so if I have this point here at 0, 0, because that's where it starts right there, and from there I'm going to go to the left 3 and down 2. Oh, and remember, I have the green line in there because I can't hit erase, and it doesn't erase right, but so that means I have a point at -3, -2. I'm going to just give you the other points that I want you to plot, because we're not going to spend time on exactly how to graph it because you're not going to have to, but I do want you to see these graphs. So the next point I want you to plot is -2, -1, and 1, 0. Okay, and then we can just sketch in that little curve that is the square root function. Okay. All right, so for this function that we just graphed, the domain, where do my x's start? -3. And I include it, right, because it's a point. And my x's go all the way to where? Infinity. Okay, and then my range starts where? -2 and goes all the way to what? Infinity. And then what we're really doing here is finding the inverse. So I'm going to change f of x to y. And then I'm going to switch x and y. X equals the square root of y plus 3 minus 2. And then I solve for y without making up math. Add 2 to both sides. X equals the square root of y plus 3. How do I undo a square root? I square it. So I'm going to square both sides. It becomes x plus 2 squared equals y plus 3. Trying to get y by itself, right? So then I get x plus 2 squared minus 3 equals y. And then once I have it in terms of y, I can rewrite that as not g. Sorry, I was looking at the one after it. F inverse of x equals x plus 2 squared minus 3. Okay, we good with that? And then for this one, I should have done that in a different color. I'm going to rewrite it. You don't have to rewrite it, but I'm going to change my color because I was trying to do that on purpose. I was trying to do something specific here. My inverse, F inverse of x is x plus 2 squared minus 3. And then the domain and range for this, my domain, these two just switch places, so my domain is now -2 to infinity, and my range is -3 to infinity. And then we can come over here and we can graph that. This point that is at -3, -2 would become -2, -3. The point that's at -2, -1 becomes -1, -2. Where it intersects the green line stays, oh, I'm sorry, I didn't have you draw that in because I forgot I had that. Go ahead, you remember your ID makes a great straight edge. These grids are actually squares, so you can go corner to corner and sketch that line y equals x in there. And then that point 1, 0 becomes 0, 1. Then you can sketch in your curve, which looks something like that. Oof, but a whole lot better. That's rough, but it's okay. Remember, not an art class. You're not actually going to have to graph it. It's just us understanding how this stuff works. Okay. And then you can see that your domain goes from -2 to infinity. Your range goes from -3 to infinity. All right. What questions do you have? Okay, perfect. All right, so let's look at B. So this is a cube root. The cube root is the inverse of, oh, I know what I was going to ask you. Let's go back up here. I skipped over some stuff that I wanted to talk about. When we look at F inverse, this is what kind of equation? What do we call it, since it's squared? Starts with a cube. Y'all can never answer this question. Quadratic. Okay, so quadratic. So it's supposed to graph a parabola, right? Does that pink thing look like a parabola? No, it does not. But because remember, if I have a parabola and I take the inverse, it looks like this, and that's not a function. but this part is. This part is, and that's why the square root function looks like it does. So when we take the inverse of the square root function, and I have that restricted domain, like my domain for my quadratic should be all real numbers, negative infinity to infinity. But it's not. We start here at -2, and all you get is the right-hand side because that's the inverse part of that. So that's where we have to restrict our domains sometimes. So technically a quadratic does not have an inverse. It does if we restrict the domain and range. Okay, and that's what's happening there. All right, let's look at B then. This is a cubic. I'm sorry, it is a cube root. So a cubic looks like this. The inverse is a cube root. It looks like this. Okay, kind of what we're expecting there are those two things. So I have a cube root. I'm going to tell you what to plot here. You're going to plot -1, 0, -2, -1, and -3, -2. Now, there's lots of ways I could connect those 3 points. I could make those into a line, right? I could also make them into a cubic, except I know that I am doing a cube root here, so this should look like something like that. But try to hit the points better than I did. All right, so let's find the inverse. We're going to change this to y. Then I'm going to switch them. So x equals cube root of y plus 2 minus 1. Then I'm going to solve for y without making up math. So this is going to become x plus 1 equals the cube root of y plus 2. How do I undo a cube root? Cube it. So I'm going to cube both sides. So x plus 1 cubed equals y plus 2. Then I'm going to subtract 2 from both sides. Oh, you know what I forgot to do up here? We didn't find domain and range of the original. So for g of x, my original, what is the domain? All real numbers, right? So we're going to go -infinity to infinity, and range is also -infinity to infinity. All right, so now that I have this set equal to y, I can say that this is g inverse of x, which is, oh, sheets and letters. That's not what I did right. I did it right the first time, and then I reread it wrong. Then this is x plus 1 cubed minus 2. In my domain and range, they switch places, but it stays the same. So this point, -3, -2 becomes -2, -3. All right, and then -2, -1 becomes -1, -2. And then -1, 0 becomes 0, -1. Now, I'm going to draw something that I do not want you to draw because it's going to be wrong. I'm going to redo it. Because those 3 points look pretty much like the first 3 points I had, right? Which means that if I didn't know what I was doing, I could draw something in like that. Does that make any sense for what we're doing? No, I mean, it connects those points, but it's supposed to reflect in that line. So if you haven't drawn in the line y equals x, sketch that in. And then, remember, we can also plot that point right there because it stays on the line. That just gives me something else to aim for there. And then it's going to look something like this. And there's your cube. Again, you're not going to have to graph them from scratch, but us graphing a couple can help you understand the graphs. You need to be able to recognize things and whatnot. Okay. What questions you got? Anything? Awesome. Let's flip it over. All right, function notation. So it is, I mean, obviously function notation is not new to you, but I think some of you still have a really hard time grasping onto the concept of what means what. Either you're having a hard time with it or you're not even bothering to look at it and think about it. I think sometimes that's the problem, like you're not even thinking about what you're looking at. So if it says here, let C of M be the cost. So C is the cost in dollars, right? Of M ounces of mangoes. So M is ounces. C is cost in dollars. M is mangoes in ounces. So what do the following statements tell you? Be sure to use units. So when we look at this first one here, the inputs, like what are our inputs and outputs? If I have C of 12, what does that 12 represent? Ounces of mangoes. So I'm just going to put ounces up here. And then, so I input ounces. My output is cost in dollars, right? So input, and because it literally tells me that, like I can look back up here. A lot of what you are going to be given on this test, it will tell you things exactly like this. So there should be no question about what your input is, what your output is. So what this tells me is that 12 ounces of mangoes, I think when mango is plural, it has an E on it. Does anybody know? I'm not an English teacher, and I don't. Okay, I think that's right. If it's not, whatever. 12 ounces of mangoes costs 75 cents. Okay, easy enough? If we don't understand what the heck it's even saying, it makes it more difficult for us to figure out what to do. So what does that 8 represent in B? Ounces. And the 0.5 represents dollars. So just like this over here, 8 ounces of mangoes costs 50 cents or 0.5 of a dollar. Easy enough? Now, when we do the inverse, does this 3 represent ounces? No, because we're going backwards. 3 represents money, right? And then 48 equals ounces. Now, technically, the way we would write this, because usually when you're doing the inverse, like I would say, okay, I've got 12 ounces of mangoes. How much is this going to cost me? But then I could go into the store and I could be like, I got $3. How many mangoes can I buy, right? So then what this is telling me is that $3 will buy 48 ounces of mangoes. Now, could you have written 48 ounces of mangoes cost $3? Yes, you're not going to have to explain this or actually write it out in your own words, like, you know, on the exam or anything. But I want you to think about like the concept of what we would be doing. This is, I have mangoes, how much is it going to cost me? This is, I have money, how many mangoes can I get? That's basically the idea here. So that means here, when I'm doing the inverse, this is money, this is ounces. So this would tell me that 75 cents will buy 12 ounces of mangoes. And if you look at A and D, you can see that you've got the same information, but it really is, your input is different. So it makes your output different. What questions we got? We okay with that? All right. It's not all about just being able to find the numbers. All right, so now here they tell us that W equals P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. What does the expression P of 25 represent? Okay, first of all, what does the 25 itself represent? The height. Because this is P of X, and X is feet, and it's height, so I'm just going to put feet here. And then the P represents what? The amount of water in gallons, right? Okay, so we can say that P of 25 represents, oops, yeah, I spelled that right. Oh my gosh. Represents. This is not even a hard word. Okay, P of 25 represents. Does P of 25 represent the height? No. So and we're not going to write out average daily required. That's a lot. Okay, so we'll just say represents amount of water in gallons required. Okay, so make sure you always have your units in there. Amount of water in gallons required for a 25-foot palm tree. Everybody understand how to make sense of that? Questions? All right. So then it asks, what does the expression P inverse of 25 represent? In this case, what does the 25 represent? The gallons, right? Okay. I have this many gallons of water, how tall can the tree be, type of thing, right? So P inverse of 25. So if the input is the gallons, then this represents the height, okay? Represents the height in feet of a palm tree that requires 25 gallons of water. We good with that? Okay. What does the equation P of V equal 50 tell you about V? All right. So equation here, what would V represent? Feet. And what does the 50 represent? Gallons of water, right? So P of V equals 50 tells me, what does it tell me about V? Well, this is V, this is what it's telling me, right? It's telling me how much water. So P of V equals 50 tells me that a palm tree of height V feet requires 50 gallons of water. Then it says to write it in terms of P inverse. So this would be P inverse of what? 50. And what does that equal? V. So if I have 50 gallons of water, I can water a tree up to how many feet? Questions? Good? All right. So then it says palm trees are on average Z feet high, and a tree of average height requires K gallons of water. Represent this fact in terms of P and P inverse. Apparently I can't erase that. So we're going to have P of something equals something, and P inverse of something equals something. Make that happen from that equation. Okay, so I'd put P of what? Z equals K, and P inverse of K equals Z. Right? That's the way inverses work. We good on that? Any questions at all? Awesome.